Why are physicians slow to respond to this? Well, as you know, they want peer-reviewed studies, and they're limited. This is a major paradigm shift for allopathic physicians like me, because we're not trained to go out on the periphery and the edge of science. We want mainstream. We want to know that all of our colleagues are doing the same thing. But I'm so far away from that now that I have to be careful I don't end up on some other planet, because I just think the model's wrong. So again, they're in this disease management mode. You know, when we're managing people, it's very easy as a primary care doctor to see somebody with heart disease, because I know exactly what their cholesterol levels should be for their risk factors, and I know exactly what medications to put them on to manage those numbers, so that now we're doing what the standard of care says. But the evidence to me is not convincing that by managing people with those levels that I'm going to prevent them from having a heart attack or a stroke. And when I was in Washington, there was a physician next to me from Missouri, a really good guy, really good physician. And I asked him, how many patients are you seeing a day? He said, 30 or 35. I said, how much time do you get to talk to him about disease prevention? No time. I don't talk to him about it anymore. I said, why not? He said, because they don't listen and I don't get paid to do it. And unfortunately, that's where allopathic medicine is, at least for primary care. We have a problem, and we have to help physicians get out of that mindset of managing diseases. Okay, we're also afraid that our peers are going to judge us, and that if something happens and we end up in a court, if we're not following mainstream medicine, we worry about legal repercussions. And for all of us, anytime we change our paradigm, that's pretty scary, and it's very uncomfortable. Okay, so here are some of the things I've heard from physicians. Water is just water. It's not just water. The Nobel Prize 2003. They said that the body has 3 buffering systems. You don't need to use an alkaline water to buffer when you already have 3 buffering systems. Yes, you do. Because even though we're all alkaline, your blood is slightly on the alkaline side. If you're not eating a healthy diet and leading a healthy lifestyle, you're going to be on the acidic side of that alkaline range, not on the alkaline healthy side of that narrow range. I've heard one physician say, why don't you just take baking soda? Well, I don't know what baking soda is going to do. It's certainly not going to penetrate cells like the alkaline water will, and it's not going to provide you any antioxidant protection. Some say, well, you drink that alkaline water, it's just going to be neutralized by the stomach acid, and that's not true, because stomach acid is not secreted until you stretch it with food or you put protein in the stomach, and that's the way it's intended to operate. So if you want to get the benefits of alkaline water, drink it in between meals. I don't even think there's harm in drinking alkaline water at a meal, but I would prefer that we all try to drink it in between meals when our stomach is empty, because it's quickly absorbed, just like alcohol is absorbed directly from the stomach. Is this the next wellness or hoax, wellness fad or hoax? It's not. There's research and there's plenty of support to show that this is going to impact healthcare in a major way for those physicians and healthcare providers who have an open mind. And finally, they want to see data. Well, I've provided 28 abstracts. I don't know how much more data you need. Some people need more than that, but I certainly don't need more than that. Now, if you're still going to say water is just water, or your prospects or your skeptics are going to say that, then what I would say is read this book, Cells, Gels, and the Engines of Life by Gerald Pollack. He's a chemist at the University of Washington. He spent his entire career studying water. Now, we all know that water can exist as a liquid, as a gas, and as a solid. He has very compelling evidence that water also exists as a gel. He calls it a liquid crystal. And the evidence, and if you watch his presentation at the University of Washington on YouTube, you'll be amazed at what water is and how complex it is and how we're just scratching the surface. These gel interfaces occur at the interface of structures. Have you ever wondered why there's a meniscus of water in a glass? Have you ever wondered why you can, in the right size glass, you can put a dime on top of that water and it doesn't sink? His research is the research that explains it. The water molecules at these interfaces are entirely water. All the solutes, the minerals have been removed. And so the water molecules pair up very, very strongly with hydrogen bonds, and it forms a very strong structure. So we're just scratching the surface of the value and the importance of water in physiology. And again, for those of your skeptics and your health-minded contacts, refer them to this, and hopefully they'll scratch their heads and start to say, maybe I need to listen a little bit more and learn a little more. In the book, we have several of my colleagues who have endorsed the book. And one in particular, Dr. Nye, is, at least locally, is probably the physician I respect more than any other. She has survived breast cancer. She is a critical care specialist who works in an intensive care unit. She's a pulmonologist. These are the doctors you hang on to every word they say when your loved one is in intensive care and on a breathing machine. These are smart doctors. And she has a water machine, and she believes in it. She says, I invested in a unit and highly recommend to my medical colleagues that they study the contents of this book with an open mind. It's not a stretch for me to anticipate the day when ionizers become standard equipment in intensive care units. Wouldn't that be wonderful? Why are physicians slow to respond to